a menu for a Greek restaurant. Set the menu aside for a second. We don't need the menu right now. And I have provided you with the Pascal's triangle because I'm so nice. Okay, so so let's look at points and chords. Do you guys know what a chord is? It's a chord is a segment that has endpoints on a circle, and technically a chord cannot be a diameter, but today we don't care. Okay? Well, yeah, because. Well, it's defined, a chord is defined as a segment whose endpoints are on the circle that does not pass through the center. So, but today, we don't care. So, see if I can get all of this in. I don't know. I didn't make the rules. So, we have a circle, and the first one says put 2 points on the circle anywhere you want. How many chords can be drawn between those 2 points? 1. So we have 2, 1. Okay? If I add a third point, how many chords can be drawn? A total, so 3, 3. Okay? If I add a fourth point, how many new chords are there? So 1, 2, 3 new chords for a total of 6. Oh, 4, 6. I'm sorry. So 5. If we add a fifth point, we add 1, 2, 3, 4 more chords for a total of 10. Okay, now, kind of. So number 5, and this is totally Tom, not me. Pattern time. It's like fun time, only the fun is patterns. Blame Tom. Can you enter? See a pattern in the number of chords, 2 points on a circle? Sorry, Tom wrote that. So, do you see a pattern in the numbers? So, +2, +3, +4. 1 less than the number of dots. Oh, you're adding, right. Okay, so the number you add is 1 less than the number of total dots up to that point. But for 6, what's the number going to be? So plus 2, 3, 4, 5 for a total of 15. 7, we're going to add 6. 21. Okay. So, how does the pattern relate to Pascal's triangle and the binomial theorem? Do you see these numbers in the Pascal's triangle? Where are they? So these numbers are along, wait. This row. What's that? He's going to print it for me so I can hang it on the wall. Yeah. Right there. What? Paper? I don't know. I just told him I wanted him to print it. Okay, so we can look at the triangle, and 8 is going to be 28, and 9 is going to be 36, 10 would be, what is it? 45, and 11 would be 55. Now, there's another pattern going on here. Okay, this is definitely the second diagonal, which is technically the third, right? Diagonal 1 is a 0 power, and then power, then raised to the first, then raised to the second. So plus 7 plus 8 plus 9 plus 10. And then those are my first differences. But my second differences are all plus 1, which means this is quadratic. So if it's quadratic, we should be able to find the equation. So pull out your calculators. Yes, go into stat. How many numbers do I need to write a quadratic equation? 3. You could put 4 or 5 or 6, but you only need 3. So go into stat, edit, and then put in any 3 points. 2, 3, and 4. And then 1, 3, and 6. All right, where do you find the quadratic regression? Go to stat, over to calc. Oops. Stat, calc, and then number 5 is quad reg. So what is the equation? 1/2 x squared plus 1/2 x. Oh, sorry, minus. So stat, and then go to the right to calc, and number 5 is quadratic regression. Okay, and it might be easier to write this as 1/2 x squared minus x. Okay, and the reason I do that, I'm going to show you another pattern in a second. So if we look at Pascal's triangle, the first diagonal is constant, right? Everything's 1. The second diagonal is linear. You're adding 1 every time. The x to the second diagonal is quadratic, and the next one would be cubic and quartic and so on. Okay? Well, this same pattern shows up here. If we had 1 dot, and then we built a triangle, that would be 3, and then 6. That would be 10, and so on. So that's the exact same pattern. I'll just ignore that. But I wonder, can we see 1/2 x squared minus x inside that? So the equation is 1/2 x squared minus x, right? And this point is 2, 1, 3, 3, 4, 6, and so on. So we could build this exact equation just from the dots. 2 squared would look like this, right? But I need to subtract off 1x, which is, get rid of those, and then cut it in half, and I get that. So I just did this. I drew x squared, which is 2 times 2. I subtracted off x and divided by 2, and I got that picture. Okay? So if on the next one, 9, I need to subtract off x, which is get rid of 1 row. Now what? Get rid of half of them. And here is that picture. Okay, let me do it one more time. So 4 squared would be, that's the total number of dots in the end. So according to the equation, I take x squared, I get rid of x, which is 1 row or 1 column. So I'm going to get rid of those. Now I cut it in half, and that picture is that picture. Okay, and that pattern shows up here on Pascal's triangle. And there are a lot of other things. In fact, 2 or 3 years ago, some really nerdy math kid at Lehigh High School found a pattern in Pascal's triangle that no mathematician had ever realized before. And none of the news, I read like 4 articles trying to figure it out, and none of the news people understood it well enough to explain what he had done, so it didn't help me at all. But I don't know. They that nobody reporting it could give specifics. They just said a new pattern, and I don't know. He was on the news, but they didn't bother to explain what it was. So apparently this is a living, breathing entity. It's still alive today. It will eat you. Did I what? I didn't. Okay, going on. So we also know in Pascal's triangle we can calculate different combinations. Shh. Are you racist? Is that the Okay. So under number 6, A, B, C, D are in a group, and you are to choose 2 of the 4 letters to go in a group. How many different combinations are there? So this would be 4, choose 2. We could go into our calculator and do 4 NCR2, but that's a waste of our time because we have the triangle. So in the triangle, remember the rows start with 0 and the diagonals start with 0. So we go 0, 1, 2, 3, 4. We're on row 4. And we choose 2, which is 0, 1, 2. So 4 choose 2 is 6. Yeah. We could use the calculator, or you could actually do I think the formula is n factorial over r factorial times n minus r factorial. So this is probably worth seeing. This is equal to 4 factorial divided by 2 factorial times 4 minus 2 factorial. No. Okay, so Aubrey's a little confused. Factorial just means that number times the one before it times the one before all the way down to 1. So this is 4, or it just means 4! Over, what is 2 factorial? 2 times 4 minus 2 is 2, so 2 factorial. So 2 cancels 2, and 4 and 2, so we end up with 6. I don't know why. So let's look at 6. So looking at the triangle, what is 6 choose 2? So 6 choose 2 is 15. You could on your calculator do 6 NCR 2, or you could use the formula 6 factorial over 2 factorial times 6 minus 2 factorial. So that's 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 4 times 3 times 2 times 1. Now we just play the canceling game. 3 times 5 is 15. Right, it's not bad. But if you have the triangle, just use the triangle. Okay? So, let's eat. How does that sound? Okay, well, have you looked at the menu yet? Okay. So, follow along. Okay? Talon, who is Tom's oldest son, and I, which means Tom, not me, Went to Washington, D.C. We ate at Zeytinnya Turkish and Mediterranean restaurant. So it's a meze style dining. Have you ever heard of that? So have you ever been to like a Thai restaurant? You wore a Thai to a restaurant? That's not a Thai restaurant. Thai. Yes. If you haven't tried Thai food, my father-in-law actually owns two Thai restaurants, and they're amazing. Yes, in in Sacramento, probably. So, um, at a lot of restaurants, this doesn't happen in America, but in a lot of other countries, you go to a restaurant as a group, and everybody orders something on the menu, and then you just share. So all of the stuff comes on little plates, and then everybody gets a big plate, and you just take a little bit of everything and eat it. Sacramento. Yeah. So, meze is specific to the Mediterranean. So at this particular restaurant, they serve these little tiny plates. You put food on them, and everybody orders, depending on how hungry you are, 2 or 3 or 4 things, and then it all sits in the middle of the table, often on one of those lazy Susans. And then you just take a little bit of everything. Okay? So, hey, I am the most important thing in this classroom. Travis. So, meze-style dining are small plates of food to share, and you order a variety, usually about 2 per person, and 2 people, oh, it's supposed to say, and no 2 people order the same dish. So, it says go to that restaurant, click on the dinner menu, but I've given you the menu. That's everything they serve. Okay? So, Talon and I, with a congressional aide, we're with a congressional aide, and we've ordered the following. So there were 3 people eating. They ordered 2 spreads, 2 soups or salads, 1 flatbread, 4 veggie selections, 3 seafood selections, and 4 meat and poultry selections. And Tom says, I must say the lamb tongue is delicious. Yee. But it's really on there, and he told me he liked it. Okay, so oh, we're not in groups yet. We're gonna save that for later. So it says in your group, but not in your group. How many ways could I select the above order from the menu for each category? Okay, so we have to look. We have to look at each individual item. They ordered 2 spreads, right? So if you look at your menu, how many spreads are there? There are 8 spreads, and oh, so the spread. Um, yeah, but you can't count spread because it's not the same size as the others. It's everything. It's bigger. Yeah. So there's the hummus, the libna, baba, housemaid. Yeah, I'm not gonna say those. Right. So there are 7 spreads, and then you could also order everything if you wanted. Well, I think that one of them isn't really counted as in the. There are, but one of them is all of them, right? And apparently one of them doesn't show up in the all 6 spreads. Yeah, probably not the. No, there are 7. Count them. There are 7. So for spreads, well, but you're not gonna order. If you order all 6, then you're not gonna order one of the other ones, right? Well, okay, so if we looked at what Tom and his son ordered, you wouldn't order the hummus and the all 6. If you wanted all 6, they're just giving you a deal if you get them all. That's what they're doing. So it's not a different. Anyway, so for spreads, How many ways are there to order the spread? 7, choose 2. Which is, we go to row 7, 0, 1, 2 would be 21. Okay, they ordered 2 super salads. So how many super salads are there? 8 for sure this time. So 8, choose 2. And so we go to row 8, 0, 1, 2 is 28. And these are soups or salads. Okay, they ordered 1 flatbread. There are 2 flatbreads. 2 choose 1 is going to be, well, we go to row 2. 0, 1 would be 2. So these are breads. Okay. And the veggie selections, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20? Did you guys get 20? So 20 choose. They ordered 4 of them. So I don't have 20 choose 4 on my chart. How do I find it? So go to my calculator. So I type in 20. Where do I find the NCR button? So go to math and go over to probability, number 3. So just the veggies, there were 4,845 ways to order just the veggies. So 4845. So these are veggies. And then they ordered 3 seafood selections. So if you flip over to the seafood selection, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 choose. They ordered 3. So we go to 0, 1, 2, 3 would be 220. So these are seafood and then meat, because apparently seafood is not meat. They ordered 4, and there are 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16. So 16 choose 4, and that's not on my triangle, so 16 math NCR 4. So this would be 1820. Okay, now that we have all the choices, each individual choice, how are we going to figure out the overall amount that you could have ordered? Add them up. So if there were 2 ways to choose the first one and 5 ways to choose the second one, does that give you 7 total? It would give me 10, because the first one has 5 other choices. So you know, bread, if you had the choice between bread and soup and then 5 different meats, you could do bread with all 5 meats and soup with all 5 meats. So you multiply those together. So we need to multiply all of these numbers together. Yes, it's big. 21 times 28 times 2 times 4845 times 220 times 1820. Okay. Why did we get a decimal if it's so large? The calculator can only handle 9 places. So this one is 2.28 times 10 to the 12th. And you need to know how to use this, because tomorrow, well, actually probably we're starting today, we're going to start using big numbers like this. Okay? What does that number really mean? 2, 2, 8, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, these numbers are so big, just do 2 decimal points and that's close enough. So that would be hundred thousands, millions, billions, trillions. So there are 2.28 trillion ways to order the food that Tom, his son, and the congressional aide ate. A congressman's aide, somebody who works for a congressman. It's a congressman with AIDS. Okay, so can we actually perform mathematics on scientific notation? Well, there are some questions at the end that will do this, so let's look at a couple. How would you do 2.54 times 10 to the 20th plus 3.61 times 10 to the 5th? Let's think about this. How big is this number? Huge. How big is this number? Not as huge. Not nearly as huge, right? So the answer is actually just going to be, it's basically that. Because the other number is so small, it's not, so it's 245 with 18 zeros. And then we have 3610000. Is it even worth adding? No, because we're going to round it off in. Yes. You can only hear me. You can't hear you guys. Yeah, all the time. Yeah. That's why we leave Colette messages. So, so really, there's no point in adding these because the difference between the number of zeros is so large, we don't even care. So for instance, if we did 2.45 times 10 to the 20th, and we added that to 3.61 times 10 to the 5th, the calculator's just going to say, oh, guess what? I don't even care about those little numbers, those little peons. So if you're doing scientific notation, my recommendation is you do it all in your calculator. I mean, something like this you might be able to look at and say, oh, wait, there's no point. But we're actually going to be dividing. So what if I did all of this divided by, and then I got to put it all in parentheses. Okay, what would we expect? It's going to get smaller, right? So we have 20 spaces, and we're dividing it by 5 spaces. Should we expect 4 spaces? So what happened? We subtracted, but there was a, but the 3 was bigger than the 2, so we subtracted 1 and a little bit extra. Does that make sense? So, well, so if we would have divided it by 2.45 e to the 5th, it would have been 1 e to the 15th. Agreed? So if I had 2.45 e to the 20th, and I divide it by 2.45 e to the 5th, these are going to turn into 1.0, and I'm going to knock off 5 zeros, and I would get e to the 15. Well, if this number is smaller, let's say 1.5, then that would be bigger than 1. Agreed? Well, what if this number is bigger than 2.45? Then this 1 is going to be like 0.86, in which case you move the decimal over, and that would be a 4. Okay? So we are going to divide those tomorrow. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So you need to be in groups of 4 or 5. Well, we're going to start today. So turn the page over. So, part 1. Suppose you were ordering for a group of 4 people. Choose how many of each type of item you would order, and really look through the, I mean, it's kind of fun to look through the thing. And everybody in the group needs 2 or 3, or if you're really hungry, 4 items. Okay? Nobody can order the same item because you're going to share. And really, the math, if you order the same item twice, gets really nasty. So don't do it. There's no restriction. You don't have to order flatbread if you don't want it. Does that make sense? If all you guys wanted was meat, that's fine. Okay? Sorry. Bad day, huh? So, go through and then write the total number of spreads, soups, flatbreads, veggies, seafood, and meats, and then calculate the number of combinations. Okay? So get it, arrange your groups. We're going to work on this today and tomorrow. You have to have 4. One group can have 5. And then those kids who are gone are going to be thrown into another group. All right, go.